Explaining implicit differentiation. Usually the equations we deal with have the formula y equals f of x with the output y on one side and everything else on the other side. These are called explicit equations, and these are the simplest to find the derivative of because you just take the derivative of the side with the x. But things are not always as simple as that. Sometimes the y values and the x values are mixed up with each other, and you can't just organize it in a way where you get the output by itself. For example, consider the equation cosine of y plus e to the power of y equals x squared plus ln of x. There's no easy way that you can get just the y by itself here. So for this, you'll have to use implicit differentiation. But for now, I'll use a simple example. I'll use the equation x squared plus y squared equals 25. And say we don't just want to find the derivative, but we also want to find the slope at the point 0, 3. In this example, you may have noticed that you could still turn it into an explicit equation, but it would be much easier to just go with the implicit differentiation just immediately. So we'll start by taking the derivative of both sides, and obviously the constant turns into a 0, and then on the other side we'll take the derivatives of each part, and we'll be sure to leave our mark as we go along. So x to the power of 2 becomes 2x, but then we'll leave our mark here, dx over dx, and then y to the power of 2 becomes 2y, and we'll leave our mark here as well of dy over dx. So this leaves us with the equation 2x dx over dx equal or plus 2y dy over dx equals 0. And we can simplify things down here a bit, and we can get rid of the dx over dx. And then now we start to solve the equation. You can start by dividing by 2, and then you can subtract the x, and then you can divide by y so that you're just left with dy over dx. And that leaves us with our derivative, which is negative x over y. And now, to find the slope at this point, we just substitute our variables in, which just leaves us with 0 over 3. And that becomes 0. So now we know that at the point 0, 3, the tangent line will have a slope of 0. So with this method, we were able to find the slope without originally knowing the explicit relationship between our variables. And this is what implicit differentiation is most useful for.